The first thing that we have is on number 1, what you have to do is when you have the absolute value, you always are putting it to 0 is right. So we go x plus 1 is equal to 0. So you would subtract 1 and x is equal to that negative 1. That is your middle point. Then remember you count around it. So backwards it would have been a negative 2, negative 3. Forward is 0 and 1. Then you have to plug it back in. Most of you don't have a calculator that has absolute value, so you have to do it in your head. So let's figure it out. We have negative 3 plus 1 gives me a negative 2. What's the absolute value of negative 2? 2 times 2 is your 4 plus 3, because we have, this is what we're doing. So we have 2 times 2 is 4 plus 3 is 7. Then we put in our negative 2. So now I have a negative 2. So a negative 2 plus 1 is negative 1. And that gives absolute value is 1. 1 times 2 is 2 plus 3 is 5. On your negative 1 plus 1 is 0. Times 2 is 0 plus 3 is 3. And these two are the same as above, so by 5 and 7. So now you can graph them. So we have negative 3, 1, 2, 3, and 7. Negative 2 and 5. Negative 1 and 3. 0 and 5. 1 and 7.
Obviously not. According to your hiccups.
So, what function does this family, what's the family? Absolute value. Your transformation would be that it got left one up 3, and it also got narrower.
Oh, yeah, you're right.
So I went narrower, and then up 3, left 1. And the last one is to state the domain and range. So the domain, remember, is your all real numbers, and your range,
What is that?
this is all real numbers.
That's what it is?
Yep, or you can write it out. It's probably written out on your test, but if you don't know that, you can write out all real numbers. I ran out of room, so, but I could probably fit it. And then your range would be your y's are greater than or equal to that y value, so 3.
What's that? Yes, you can.
No, I can't.
Hold your breath strong. Yeah, you have to hold your breath for like you can breathe.
When you're doing your absolute or your linears, so this is now a linear,
Hold your breath. Hold your breath.
you can do a t-table on linears of 0 and 1. And so we got 0 is 5, 1 is 4. So I got 0, 5, 1, 4, and then I would use a straight edge to connect it. You can do more points, but we know it's linear, so we only need 2. So it is the linear function. The transformation on linears, remember, only go up or down. So this would go up 5. it is flipped as far as it's a negative slope. And lastly, when you're doing domain or range on linears, they both are all real numbers. Remember that this is all real numbers. Your y equals 7. What type of line is y equals 7?
Constant.
It is a constant. It is a horizontal, is right at 7. So we go to 7. And this is called a constant.
Wow. Moses.
When you do the transformation, remember that it's from your 1.
They look nice. That's why I said.
So from 1, ladies and gentlemen, how many did it went up 6?
Wait. Oh yeah, you raised.
Because the parent function is at your 1. And your domain and range, your domain of this is still all real numbers.
Wait a second. Why is it up 6?
Because it's always from your parent function. Your constant parent function is y equals 1, which is here. And so from here to there is 6. But your range is your y value, so it's y is equal to 7. Last one, and then I'll take requests. On 3, remember that on 3, you have to find your vertex. So it's -1, -2. Y is equal to, this is HK. Your formula that you want to make sure you write on your paper, that front and back, is Y is equal to A times the absolute value of X minus H absolute value plus K. A is only going to be positive or negative 1. So because it is upside down, it is negative. So your equation would be Y is equal to a negative absolute value of X minus -1, so it's plus 1, absolute value minus 2, which is our equation right here. All right. Those are the ones that I wanted to get done. Now I'll take request of any from the packet that you guys want.
Wait.
You have 4 minutes?
Yeah, let's just pack it up. Let's gonna do that.
Put a stop in it, Bezak.
Seriously.
Done.
Lose it.
Done.